Wait, it's generating assembly. Hi everyone, in this video, I am building my own programming language from scratch. But why would I even do that? So, I recently learned C++. I liked it for its speed and low level control. Before that, I mostly used Python and JavaScript. They are clean, simple, and fast to write. But when I worked on performance heavy project, I started noticing their limits. Then I switched to C++ and everything changed. Even simple tasks needed a lot more code, like reading a file in Python, just a few lines. In C++, way more boilerplate code. And honestly, that slowed me down. I was spending more time writing small things instead of building actual features. So I thought, what if there was a language that's as simple as Python but as fast as C++? I explored languages like Mojo, Julia, and Go. They are powerful, but each has trade offs. Some are easy, but not as fast. Others are fast, but not as simple. So I decided I build my own, not to replace C++, but to understand how programming languages actually work. Because behind every language, there is a compiler doing the real magic. So, how does a compiler work? Most compilers follow three steps. First, lexer. It takes your code and breaks it into tokens, like turning a sentence into words. Second, AST, or abstract syntax tree. It organizes those tokens into a structure so the computer understands relationships. Third, IR, intermediate representation. This is where your code becomes low level instructions, closer to machine code. Now it's time to build. I choose C++ to write my compiler and designed a simple syntax, a mix of Python and JavaScript. And I name it Obsidian. Yeah, inspired by Minecraft. For version 1, I kept it simple. Variables, arithmetic, and print. Let's take a small example. Print 5 plus 3. Looks simple, right? But behind the scenes, a lot is happening. First, the lexer reads this line and breaks it into tokens. Print keyword 5 number plus operator 3 number. Then the parser takes these tokens and builds a tree structure, where plus is the root and 5 and 3 are its children. This tree helps the compiler understand what would happen first. Then comes the code generation phase. It converts this tree into pseudo assembly, something like float 5, add 3, print. Now, why pseudo assembly? Because real assembly is complex. Pseudo assembly keeps things simple and easier to debug. It shows what is happening without worrying about CPU specific details. And it works. It successfully generates code from my language. But this is just the beginning. In my next video, I add if statements, loops, and operator precedents, and even generate real x86 assembly. Then we compile it into machine code using NetWide assembler. So if you enjoyed this, hit like, subscribe, and I see you in the next one.